I'm going to share the screen. Okay, and so that way you can follow along with the video. I'm going to, yeah, we're going to use the virtual machine. Oh, I'm sorry. Yeah. You guys should be able to see it. This is similar, not difficult really, except that part of the encryption with CBC, right? Because we're going to need an initialization vector, right? So you guys remember how it works. We're going to do what? Who can tell me how CBC works? Every block we're using what? The previous cipher, exactly. And that makes it a little bit tricky. How are we going to implement that? And remember, this is not even like data encryption standard or AES. This is just simple CBC mode of operation. But as you know, it's a little bit more secure. Okay. All right. And again, for this assignment, don't worry about the key. Obviously, the secret key you have to share with your partner. And then just make sure you document really well in your report that you're sending the message encrypted and achieve confidentiality. I will, of course, write it out when I post the link, but yeah. That actually will conclude symmetric key encryptions. And then next week, we'll start asymmetric, right? So if you remember what is asymmetric, the goal is now how do we securely exchange the keys, okay? Again, we'll go over the algorithms a little bit. And then once we're done with that, we'll start focusing on applications. So we'll be using libraries and then combining everything together, digital signatures, certificate authorities, and all that higher level stuff, HTTPS and so on. All right, so, but we still need to cover asymmetric. And so we'll start that next week. All right, so yeah, so let's go ahead and start writing code. So I was playing with this earlier, but I'll start a new script from scratch and follow along. This code is posted on the GitHub, right, under XOR.py, so you can just reference that one, and then I'll be kind of explaining it out as we go. Okay. All right, so let's go to the desktop. Okay, and let's do this under XOR Python. Okay, so I'm going to create a new one. I had written this around the CBC, so I'll remove that one. Okay, so I'm just going to create a new script. I'm going to call it CBC XOR .py. Oops. Okay, I'm going to call it 2 just because. All right, so let's go ahead and get started. Again, this is somewhat repetitive, but hopefully it'll help you to kind of, grasp the main idea. Remember, when we do the practical exam on week 12, around week 12, all these scripts might come back, right? So you'll need to use a lot of them and understand how they work, because remember there, the point is I will have hidden a message, and I'm going to do a whole bunch of encryptions. It's like a scavenger hunt, so I'll give you clues, obviously, but you need to use these scripts, okay? So I won't ask you to write them from scratch, but definitely understand. All right, so let's get started. So you guys know the basic approach. We're using XOR. So I'm going to create a main function that I'm going to invoke, right? So I'm just going to call it main. And then I'm going to define it. And we should understand by now the basic structure of this. We'll be using some common functions. We're just going to do define main like that. Okay, so a few other functions that we're going to need. Break message, of course, to break the blocks. It is our goal in this one to be able to read in from a text file. our message, right? So this time around, so let's do break message. Which is what we would use to create the blocks. And this, might take something like message. Okay, I'm 1, 2, 3, 4, remember, and then I'm just going to put the word return in here. For now, I'm going to do the same here. 1, 2, 3, 4, return, right? Okay, other functions that we need are, the random function for modules. So we can do from OS import urandom, okay? So, and then we're going to generate our key. So we can define a function, gen key of a specific length, right? And that's the length of the blocks. Okay, so length. So this one just returns a byte array, 1, 2, 3, 4. So return byte array. And we're going to use urandom to initialize it to a specific length. So urandom length. Okay, so that's basically it. Very similar to before. All right, then we're going to need our encrypt functions. There's a couple of ways that we can do this. Mainly, the main issue will be like the formatting of our data. Some of it originally is a string. Then once it's XORed, it's a byte array, right? That's the trick. And then when we're decrypting, it's a byte array. And then we need to switch it back to a string. So how do we do that, right? So you can have 2 XOR operations in a function, or I may just create 2 encrypt functions called encrypt1, encrypt2, and decrypt1, decrypt2. All right, so I thought to myself that encrypt1 and encrypt2 is easier to understand. So I'm going to take that approach, but just keep in mind you could do 1 single function too. Okay, so let's just define that somewhere in here, we're going to do encrypt. So encrypt, right, and just 1, 2, 3, 4, return for now. And then over here, the final one, decrypt, define decrypt, colon, 1, 2, 3, 4, return as well. All right, so break message. Let's start with the main function first. Kind of that's what's going to drive everything. So let's go over here. So we invoke main. And I'm just going to do this with one message, like hard-coded in here. And then to add complexity, we can think of reading in a file. All right, but let's just do it here. So I'm going to do my message. And, this is a message. Let's just add some information. Okay. Just for now, so that we can have something going on, right? Of a specific length. It doesn't matter the length right now because it'll work for any length. Okay, everyone with me? Okay, so just some message. 1, 2, 3, 4. All right, then the next thing would be basically we can create the list of blocks, right? So that, we can do that. So we should be able to do that by now. So block list, maybe. List. Okay, so we have a function break message here. So let's define that one and use it. So I'm going to do break message. Break message will take my message. Right. All right, so let's go into break message basically and define the blocks. Okay, so we're going to create a list of blocks, right? These are the things that we're going to encrypt with the key. So those will match. So list of blocks. right? We initialize it. All right, then there's a couple of ways that we can do this. I'm just going to take the same approach as before for I in range, right? And we're going to basically start at 0, comma, to length of message. And we were using a step size, right? So in this case, the step size can be, we should define that, right? So we defined it to be 8, I believe, the last time around. So that's something we might want to define here. Length of block. And that's going to be equal to, say, 8, right? So then we can pass that parameter to this function. Len of block. Okay, so we're going to go over here. Len of block. Any questions? Okay. So then this is the parameter that we're going to use here, len of block, to have hopefully blocks of size 8. Okay. So now that we've done that, we can go ahead and scoop 1, 2, 3, 4. I'm using 4 spaces as indentation. So each block is going to be equal to message. Okay, and then it starts at I 2 I plus len of block, right? Which should, oops, sorry, underscore of block, which should be 8. So don't hard code it so that you can actually replace it if you need to. Okay, and then once we have that, what do we do? What do we check for? Padding, right? There's going to be the last block, which needs to be, may need to have padding, if you remember. So I'm going to do if len block equal equal length of block, right? So if it's 8, then what do we do? 1, 2, 3, 4. We just add it to the list. We don't need to pad it. So list of blocks dot append, and we add block, right? So hopefully that's clear. Then we can just make sure it's aligned with the I there, and then we can do else. This is the part if the block is not of size 8. 1, 2, 3, 4. We're going to need to do some padding. So you can just calculate the difference. So len of block minus len block, right? And that gives us the amount of padding that we need for the message. So now we can just add it to our block, basically, for I in range C. 1, 2, 3, 4. And now this is going to be block equal block plus, and then you can add some value here, whatever you want is fine, just like a space for this. Okay, and then is that it? Are we ready? We return list of blocks, right? Right, good. I was hoping somebody was. All right, yeah, so we need to add the last block, right, into our list. So we padded it, but it's not in the list yet. So list of blocks. Okay, and dot append. and we append this block, but this block should now be padded. Okay, very good. Thank you. All right, so hopefully that, as you can see, that's the exact same function. So I'm not going to do this function again, but I think you guys pretty much get it now. All right, so let's see the result of this. So we probably want to print out block list, right? So let's go ahead and print block list. Okay, and if everything is correct, we're going to have our list of blocks. All right, so time to run it and see if we get any errors. List of block is not defined. Okay. Plural. Try it again. Oh, yeah. Case I there. Right? Hopefully that'll do it. Okay. All right. So we have our blocks, this message, so something, right? And we can see that the padding is there. So, basically we've got our information. Now in this problem, we're going to need a key, but because we always need to have, in the next iteration, we're going to look at the previous cipher. For the first one, we need an initialization vector. So it's effectively like we need two keys, although only one of them needs to be kept a secret. So we're going to use gen key basically to generate both the key and the initialization vector. All right, when you exchange this with your partner, you need to provide both of them so that they can do the decryption on their end and read the message. Remember, you're going to send them some secret message, okay? Take these things seriously, as I said, because in the practical exam, you won't know what I've hidden unless you do things right? So you'll get encrypted messages. You need to find the actual sentence. Okay, so we're going to go ahead and in main, we've printed the block list. Now we can go ahead and generate the key and also the initialization vector. Okay, and they're just going to be of the same size. Okay, so I believe we created the gen key function already, right? Yeah, gen key is there. So we can just make a call to it. Okay, so we're going to say gen key. Gen key. And we can do len of block. Yeah. Okay. We're also going to, oops, sorry, there's an N this in here. And we're also going to do gen key for the initialization vector. Okay. Yeah. We can print them out if we'd like. So we can print key. And we can print out the initialization vector, IV. Okay, so let's go ahead and try those out. Be sure it's working and we don't have any errors. Length typo there. Okay. Try it again. Yeah. All right. So we've got, they're different, right? Yeah. So they should be different. So we've got the key, and then we've got the initialization vector. We've got almost everything that we need now to perform our encryption. Okay, so we're going to perform our encryption. I'm going to do the encryptions in the main this time around. So let's think about this, or I guess I don't know. I'm going to create a new function for this. All right, so let's do go over here. I guess I'm going to change the code a little bit from what's on the GitHub. So we've got both the key and the initialization vector. Now I'm going to invoke a function called encrypt message. Okay. So this is going to take several parameters, right? So this will need to take the key, the initialization vector, probably the block list, and probably also the length of block. All right, so these are the parameters that might be useful to have. Okay, so let's do that. Block list. Keep doing that. Okay, block list. Okay. Yep. Then the key, then the IV, and len of block, basically. All right, encrypt message, then it's going to give us the cipher. Okay. So let's do think of how let's return a list for now. So list cipher, right? Or cipher list, all right. All right, so now encrypt message. Let's remember that one. We're going to go over here, and it's going to be called encrypt message. Okay, so this will take the plain list. Let's call it block list as well. So block list, right? What else? The key, the initialization vector, and length of block, right? You guys see that? Pretty much the same thing we've done before. This is, however, where it gets different, okay? This is where we have to do some additional. Okay, so we've got let's do trying to think what might be better here. I think I'm going to do the two functions, as I said, so it might be more obvious. Okay, so then this would be, what I mean is I'm going to do encrypt 1 and then encrypt 2, okay? And it's kind of to highlight that we're doing this twice, okay? That's kind of the idea, so that you can see it. So the first time around, this would take the IV, right? And it would take the a block, basically. Okay, so we are passing a block list, correct? Right? So since we're passing a block list, we can actually do like a for loop here, make things easy. So I'm going to do for I in range. So for I in range. And then here I can do what? Length of what? Block list, right? So I'm going to do block list. Block list. So length of block list. So this should give me all the number of blocks in my block list, right? That's the idea. And then I'm going to take each block and try to encrypt it, right? So you guys can take a look at this and tell me if this is CBC or not. Maybe I'm not doing CBC, right? So convince yourself that this is correct. Okay, so then obviously I'm going to move these 1, 2, 3, 4. I'm going to move this one 1, 2, 3, 4. And I think this is like, I like this approach because it's like we know encrypt 1, encrypt 2, and then we can build those encryptions however we want them inside. All right, so that means we need to pass to the operations the block itself, right? So the block would come in here. So I can just say block list, right? And then the index, right? I. So that way I'm passing the first block in the list block. Yeah. Okay. So I'm passing that. I'm passing the initialization vector. So this is the first iteration. Remember, we only use the initialization vector the first time around when we need a block. The next time around, what are we going to need? The output, right? The cipher that we get here becomes the initialization vector. So that's really the trick, hopefully. So then this would become like cipher 1, let's call it. You see that? Cipher 1. And then, so now we're going to do what? In encrypt 2, we pass cipher 1, right? And what else do we pass? The key. This is where the key does come into play. Now, the key is used for every block, right? If you remember, if this was ECB, it would basically be what? Just that, right? That would be ECB. Just the block and the key. But because it's CBC, we need to have the previous block. And so that's why we do this, okay? So initially, we need that initialization vector for the very first time. So encrypt 2 then will give us actually now the, let's just call it cipher 2, yes, to keep it consistent. I'm missing a letter here. All right, so cipher 1, cipher 2, let's align them a little bit, just like that, okay? And then, what else do we need to do here? So if you notice, I haven't even looked at encrypt 1, encrypt 2, trying to keep that a little bit separate, just so that it doesn't complicate this logic, right? So what are the 2 other steps that I need to have in here? I need to obviously append this. This becomes now the actual encrypted message, right? So we probably want to create a list here that we're going to return. Okay, so let's just call it list of ciphers. And then we could, if you want, you can make this into a string, etc., write it out to a file. It becomes the thing that you're going to send to your classmate. So remember, this is what you need to send, okay? And so we're going to append to it. So I'm just going to do list of ciphers dot append. And which block do we append here? Cipher 1 or cipher 2? Cipher 2, right? So we're going to append cipher 2. Let's remove the question marks from there. And then the final part is, in the second iteration, we need to use, we're going to need an IV again, right? But we already used it. So instead, we will provide what? Cipher 1 to replace IV. So I'm going to try anyway. Or rather, it should be the last one, right? Actually, so it's cipher 2. So IV will be cipher 2, right? Because you want it to go through the IV first and then through the key itself, and that becomes, so that way, next iteration, we use the previous one. And then the third, and we're always replacing every iteration. We get cipher 2, goes in here, we replace it and so on. Make sense? That's it, right? So now all that remains is for us to define encrypt 1 and encrypt 2. And these are basically more like the technical thing, right? So it's not the logic itself anymore. The logic has been handled here. And instead, now I have, I have encrypt 1 and encrypt 2 to define more technically. Okay, so once we're done with this, we should return list of ciphers. Okay, list of ciphers gets returned. So let's go back to the, let me actually save this before I lose it. Okay. So let's go back over here. So we've done encrypt message. Encrypt message gets invoked over here, right? And it returns cipher list. Okay, so that's where we are. We would probably want to print it out at this point. So I'm going to do 1, 2, 3, 4, print cipher list. Oops. Okay, so we want to, print it out. So now what we need to do is we need to go in and define what encrypt 1 and encrypt 2 are, which should be just that caret operation that we had done before. Okay. And it's just those two functions are different because the first one deals with the plain text message. So that's the ASCII characters, a string. We need to convert them to like an integer value. Then after that, everything is a byte array. So we don't have to do the operation, right? So that's why I have them as two separate functions. You could probably find a more efficient way of doing it. And I leave it to you guys to code it better. But otherwise, I'm just doing it like this. All right, so then encrypt 1 and encrypt 2 are going to get defined here. So they can be two additional functions. Okay, they just return the block, the encrypted block, basically. So let's do the first one, encrypt 1. Encrypt 1. Okay. So encrypt 1 takes a plain text block, right? So I can call it plain block, comma, and it takes some kind of a key, which is an initialization vector. You could call it here. It doesn't really matter. So I'm just going to call it key, okay? But just be aware it's basically the initialization vector or the previous cipher once we get past. All right, so that's encrypt 1. So then here, 1, 2, 3, 4, just adding 4 spaces. Now I'm just going to do the encryption part, and then we're going to return it. So let's do for I in range, right, of length of plain block, right? So plain block, just like that. Okay, and this one then allows us now to basically do the caret operation, which if you remember is the XOR operation. Okay, so here we're going to do key I, right? And if you remember, caret just means the XOR operation with the plain text or plain block, sorry. So plain block, okay? But it's going to be the index one, so I, like that. And remember that because this is an ASCII string, we just need to convert it to number, but we've already seen how to do that with ORD. Okay, so ORD. So this, we've used this a couple of times already, and we're using it one more time. Okay, now we only need to do this the first time when we're dealing with the string. Okay, now once we have this, we can return this as a byte array. Okay, so you can just say byte array, open parentheses, close parentheses, and it'll look hexadecimal as we've seen before, and then just do the return. And hopefully, if we didn't make a mistake, that's it. All right. Encrypt 2 will be very similar, but without the ORD. So in essence, even simpler. Do you guys see the reason why one has ORD and the other one doesn't? So if you remember, one is the plain text block, right? Like hello world. So we take those letters, convert them into numbers, and then XOR it. In the second iteration, it's all a byte array already, so you don't really have to do that. Okay, so I'm going to do return byte array, in parentheses, ORD, plain block. So just confirming. I think it's correct. Okay, so let me write the second one, and then we're going to try it. And obviously with this one, we'll know if everything works because it has to decrypt, right? Decrypt back to our original plain text. So I'm going to do define encrypt 2. Okay, define encrypt 2. That's this part over here. Same operation pretty much, except no ORD. So let's do it. It should take plain block and key is pretty much the same thing. So plain block, comma, and key. Okay, just keep it consistent. All right, so now 1, 2, 3, 4. So I'm just gonna do the same. So return byte array. Okay. And then the same list comprehension. So I'm going to do for I in range. For I in range of length of plain block, right? Exact same thing. Then over here, I'm going to do key I, right? So same idea. Caret, which is the XOR operation, right? And now we just do the plain block I without having to run it through ORD. That's it. So if you notice, it's almost the same thing. So plain block I, but no ORD here. Just take whatever that XOR is and, XOR it with the key. Does this make sense, guys? That's basically the only difference. And that's why I have two functions, but I think hopefully this is a little bit clearer to separate out the technical from the logical part of it. Any questions? Yes, please.
You got a bar and return byte array and array.
Oh, yeah. Thank you so much. Yeah. All right. Perfect. Yep. I will post this code, I think, on GitHub since it's a little bit different from the one I already, it's like they're the same. I think I took a slightly different approach on this one. But I'll post this one. All right. So let's try it. Please, you guys go ahead and try it. The goal is that it should print out list of ciphers. So hopefully can do that. Yeah, cipher list. All right, so let's try it, see if it errors out. Yeah, it's typo, so it's an easy fix somewhere. Where is that error?
It's an encrypt message.
It's an encrypt message?
Yeah, it's block LSD.
Okay, yeah, I see it. Thanks. All right, try it again. Cross your fingers. Okay, good. Good. All right, so we have something, right? We have a list. I can confirm that it probably looks like a list because there's commas in there, right? And they're byte arrays. So now we are going to do the second part, which is what we haven't done before. We've done the hash calculation similar to this, but without CBC. So now we've added CBC, we've got these, and then we're gonna decrypt it. What you guys have to do is, remember, you have to send this to your friends. So how are you gonna send this to them? Do you see what I'm saying? And then read it into your code efficiently. So that's a question to answer. Okay. But let's finish it. So let's do the decryption to see if we get the original message. So now it's basically the same process. So we're going to go here into the code. Okay, so now we're going to define. So we just printed cipher list. And now we have to proceed to 1, 2, 3, 4. Okay, so we have to proceed to do the decryption part. Okay, so now let's do list, to be consistent. Actually, let me think about this. How did I do this? Okay, so let's actually do decrypted for now. List maybe. And we're going to say decrypt cipher, right? Okay, so this should take, let's think about this. This should take, list of cipher list. Cipher list. Okay. The key. Initialization vector. So now let's define decrypt cipher. So this is a little bit harder, right? This one is not so trivial. Decrypt cipher. Okay. So we need the trying to think. When we go back, when do we need, the question I'm trying to formulate here is, when do we need the initialization vector, in your opinion? How do we do that? Because we need to do this like in reverse, right? Do we start at the end and work our way back? Is that what we will need to do? Or can we start at the beginning if we just have the initialization vector? Do you see where I'm going with this?
You have to start at the back, and then
I don't know.
use the initialization vector in the last block.
Maybe. You see that? Or maybe it's equivalent somehow, right? So that's the whole thing that we have to kind of like think about, right? It's not, the reverse is harder, right? The decryption. So let's think about it. But yeah, so let's see. Let's put it together and then you guys can help me out. At least we will know if we got it to work, as we'll get the message. List of cipher. All right, so let's kind of like, I'm not sure exactly, so let's just kind of build it and we can troubleshoot it, okay? And that way we can go over it. So decrypt cipher would take, let's just call it list of cipher because it is a list. List cipher. We've got the key, so yeah, we would have that. We have the initialization vector, we would have that. Length of block, we probably don't need that because it's padded, I suppose. And let me just double check over here. Okay, yeah, so those are the three things that I'm passing. So then we need to somehow iterate through the list of ciphers, right? So let's do here. All right, so, and also we're probably going to need a list of decrypted blocks. Okay, this is where we're going to collect our data, right? So now probably we need some kind of for loop. So I'm going to do for I in range, and we just got to get the order correct, and then we should be good, I think. So for I in range, like that, right? And then we're going to say what? Length of list cipher, right? That's a list of ciphers, so we know how many we've got in there. Okay. 1, 2, 3, 4. All right, now we need to decrypt, let's say. It's going to do one function. Decrypt list of ciphers. List cipher, sorry. I. Right? List cipher I. And then key. So this is the first one. So this should give us a cipher that then needs to use the initialization vector probably to get the original one, right? If we're looking at the first one, what we need to think is what it used, right? Like what was the thing that it used before? So if I'm starting at the beginning, right? And so I have to find that vector basically. So cipher, the first one, the key. All right, so let's try this on the whiteboard, maybe. Oh, I don't have that set up. Let me get that. Right, so we're on the whiteboard, right? So let's think about how we encrypted things and then how are we going to decrypt things. Okay. So how did we do it? So we have, let's say, a message, right? right? These are the, I'm going in the encryption process first, plane 1, plane 2, plane 3, and so on, right? Until plane, let's say 6, the last one. So this one needs the initialization vector, right? And these two got XORed. Was that the order that we did it? And then this gave us, let's call it temp 1. And then we XORed this with the key. Right? Was that the order that we did it? Let's take a look at the code, I guess. So this is what we have to solve. This is the problem. Let me see the code. We did encrypt message. We take the block first and the initialization vector. And then that gives us cipher 1. And then we take cipher 1 and the key, right? And produce cipher 2. And then that's going to be used in the next iteration, right? Do you see that? So that's kind of the idea. So I have to think about reversing it. So this gives us cipher, you know, the thing that we use. So in the next iteration, then we take this one, right? Yeah. That goes in there. And that gives us temp2, I guess. And then this is the key. Like that. And then this gives us cipher 2. Let's call it C2, and so on. So now, how do we repeat this process? Let's do one more of these. This should go in there, right? This produces T3, temp3, I'm calling it. XOR key, right? And that produces C3. Do you guys see that? Now I need 2 decrypt functions, right? 2 XOR operations. One is gonna be with, let's take a look at like here. One is with the key. So that should be straightforward. As long as I do, C2 is what I have. So I have a list. Now, one thing that's important, my list is these, correct? Let me change the color. So I want you guys to tell me if you agree. What I'm saying is when we pass a list of ciphers to the code, to the new function, we are passing this one, correct? Yes? Okay. That's what we're passing to the function. We also got the key. So that's good, right? So then stands to reason that what we want is P1, P2, P3, PN or P6, yeah? Okay. So if I take C2, which I have, XOR it with the key, which I have, I get this one, correct? And then that one, I need to XOR with this one, correct? To get this plane, correct? Well, if you think about it, if I know I'm in iteration 2, the one that I need is, if this is I equal 2, then all I need is I equal 1. Do you guys see that? And that's it. So I can sort of work my way back through that. But if I'm in 3, for instance, right, then I'm in iteration 3. So I XOR it with the key and get this, and then this gets XORed with I minus 1, which is the previous one. And you just have to know that you don't have, for this one, but this particular one, it's going to be 1. 1 minus 1 is 0. So whenever it's 0, you cannot, grab it from here. Instead, you use the initialization vector. Do you guys see that? Is this making sense? How we can approach this one? So we can actually go forward, basically, given that we have the ciphers here. All right, so let's try it out. See, so I'm going to do, so I'm going to try to remember this. The first iteration will be to grab the cipher and the key and XOR it, okay? And that should give me a temporary thing. And then that one with the I minus 1. All right, so I think that seems reasonable. Let's go back. So now that we understand that logic, we need to kind of implement it here, right? So we would take the first cipher block. So actually we probably need an if statement here, right? So we're going to say something like if I equal, it's I is going to be 0, but it's the first index value, right? So what we need to do is if I equals 0, that's the first one, right? So there is no previous cipher for that one, so we need to use the initialization vector. So this would be for the IV one. Okay, 1, 2, 3, 4. But that's actually for the second decryption. So we have a first decryption. We are calling it temp, I think. So decrypt, right? So this takes list cipher I with the key, correct? With the key. And then that temp should be this one, which would give me the plane that I want. Oh, that's this one. Okay, so list cipher key, that gives me temp. And then this one, for this iteration, IV. What do you guys think? Does it seem reasonable? And so now if it's not else, right? Else. 1, 2, 3, 4. Temp is gonna be decrypt. And bear in mind, I may need to change this from 1 and 2, right? So I didn't do that because we're going back to plain. So here it's decrypt 1 again, right? But now we're assuming that it's not the first iteration. So we're like second, third, whatever it is towards the end. So there's always going to be a cipher block that's the previous cipher block that went into the next one. So then I would go back to the whiteboard here. Right, so let's say I'm in this one, the block key, okay, block and key, first one. Okay, so that's going to be here. List cipher I, right, comma key. And then, oh, this should be plain, sorry. And then here, plain, let's say, decrypt 2. Temp, right? Comma, what? List cipher I minus 1. I minus 1. That seems reasonable, right? So we're just trying to work out how we did it before. And, it seems like that's how we did it, right? So we started here. We would take the block and the key was the last part, right? That would produce that. This is temp, that's the key. So I'm trying to work my way back. Right, key to produce a cipher. So now I'm just trying it the opposite direction. Okay, so I think, yes. And then once we have this, we would take that plane and just add it to the list. So we would need list of decrypted blocks dot append. And what do we append? We just append whichever plane it was, and then we would be returning list of decrypted blocks. Like that. Okay. So then list of decrypted blocks would get printed out. Decrypted list. All right, so now what we would need, let me save at this point. We need to still define the decrypting functions, right? So we need to have decrypt1 and decrypt2 defined. So decrypt1, decrypt2. So this is just byte array. This is byte array, right? So that should be kind of the reverse of the previous encrypt1 and encrypt2. I'm going to define decrypt. This would be, let's call it cipher, comma, key. Oh, and this is 1, right? 1, 1, 2, 3, 4. So then we're going to do return. Oops, sorry. Byte array. Return byte array. And then we just perform the same caret operation, the XOR. So for I in range, and then what? Length of cipher, right? And we're going to XOR key. So this is pretty similar. Caret, right, which is the XOR operation. And then should be cipher. I. You guys see that? Now the last part is where we need to do the XOR again and then get the string, right? So the character. So that's going to be decrypt2. And that's kind of the end. So hopefully if we got the logic right, this should work. And it's a secure cipher. It's a secure mode of operation. Unless we've made a mistake somewhere, then we'll have to fix it. All right, so this one, decrypt2, it's a cipher. Key, right? So 1, 2, 3, 4. So now let's just try this. Let's do return The thing that might be difficult here is the data types. So we need to figure that one out. Decrypt to 4i in range. Okay. Oh, let me do the square bracket. Okay. The 4i in range of length cipher. Okay. E I caret cipher I. But now we are back to where we need the letter, right? So that's where I think this last part would require us to, if we did ORD at the beginning, right? Then now we need to go back to the letter. And that was CHR, if you remember from the substitution example that we did, the very first one. I mean, I think this is how. All right. And that would be, if I look at decrypt 2, still a list. Sure. For now, if I look at decrypt cipher, yeah. Like that. Make sense? So I think the logic is correct. I'm just not sure about the data type. But let's try it. So this, we should be able to try it now. So I'm gonna do Control X. Okay. Maybe 2. Okay. Try it again. Huh. I'm actually surprised it worked. All right. All right. So did it work? This is a message. 1, 2, 3, 4. Yeah, I think it worked. I'm quite happy with this. Yeah, I think it worked, right? So now you guys can try it out with something else. So basically now read in some text. Let's do that, right? So let's actually read in some text from the terminal, and then we're going to kind of summarize what we've done. And then if you guys have any questions, let me know. All right, so instead of reading in like this, let's just be able to. So remember, when you do your homework assignments, I prefer if you put your own personalized messages in there, like, hello, my name is so-and-so. All right, so I'm going to do here, print, enter a message to encrypt. Okay, so then I'm going to say my message is equal to input. I believe that'll work. So then we can type some kind of a string in there, and then hopefully that'll work. All right, so let's try that. Clear here. So let's run this one. Okay, enter a message to encrypt. So hello. Today is Thursday. 9 September 28, 2023. And it is sunny. Okay, something like that. 1, 2, well, yeah, just like that. All right, so let's try that. Hello, today is Thursday, September 28th, 2023, and it is sunny. Yeah, so it's working, right? So we were able to encrypt and decrypt, and this should be a secure cipher. We have implemented CBC. You guys saw that. Now, you could have done it in reverse, of course, but you saw that basically I went over the logic in the whiteboard. So you basically could, just by doing the I and the I minus 1, able to repeat the process. Is this clear enough, guys? Does this make sense? Are there any questions on this one? This kind of concludes symmetric encryptions. As I said, CBC gets already pretty, difficult. And then DES would be even more difficult. You already know, implementing the Feistel network would not be trivial. So I'm not going to go beyond this, but we did cover the data encryption standard algorithm, so you know how it works. Just remember, an AES would be even more difficult, and it uses matrix multiplication, so it's just even more difficult. Okay, but that kind of is the last algorithm that we're going to do in code for symmetric encryption. We've done pretty secure symmetric block cipher. All right, any questions on this algorithm in general? I will post this one on the GitHub in a sec. So what do you have to do? Obviously, get this to work. Again, you must always show evidence that you can use these. Okay, so let me switch over. And you need to work with a partner again. And I strongly encourage, not strongly encourage, you have to work with a partner. It's not the same. Believe me, at some point in the semester, you have to do demos and things, and I'll sit with you and a partner where you have to do the encryptions. If you do it alone, you're going to miss something. I promise you, especially once we get into RSA, where there's public and private keys, and every party needs to have a public and a private key and a secret key and a whole bunch of other things. So get into the habit of making these work with your partner, okay? So what I want you to do with this example, I'll write it up, but basically the problem is to send a secret message using this algorithm, CBC block cipher, to your partner and achieve confidentiality, okay? Makes sense? Now, the thing that we can add now is how to read in from a text file, but also you have the challenge of how to send this, right? To your partner. So you have to save it to a file as well, basically. Do you see where I'm going with this? So that's kind of what I would recommend going forward, is to implement the code to read in from files and to save to a file, because that'll make your life easier just to, okay, this is the cipher. However, it adds more complexity because now you have more files to play with. Okay. So, but that's going to be, RSA is complicated that way. You have to have a whole bunch of files in order for it to work. All right. So let's go ahead and do that part in the time that we have left. Let me just get my charger. All right, so the next part should be straightforward. How to read the text from a file should not be very difficult to do. Okay. All right, so let's go back to the code then. So are there any questions on the overall logic of anything? Do you need me to do a summary or review of all the steps? Is it clear for everyone? Yeah, what's up? Okay. What do you mean nothing pops up? Like the... Okay. So you're saying you do this and you don't get the message?
No, just go to the next line.
Okay.